Hello everyone, my name is Aaron Gors and this is my Project 2 presentation for CE 570. Now for this project we were tasked with creating a composite shape by coding in a couple of different shapes into MATLAB. So given that we're in Indiana, which is essentially the corn capital of the world, or at least the United States, my shape of choice was a silo. So my silo contains three different shapes. I have a hollow cylinder that functions as the shaft of the silo, a hollow hemisphere that functions as the dome top, as you can see in that image there, as well as a concrete slab that the silo will be sitting on. So given that we have a limited time frame for these presentations, I won't be able to go into as much detail into the code itself, but I'd like to highlight a few things. As you can see in the parameterization for all three of these individual shapes, I have the simplest parameterization for a cylinder, a sphere, and a slab individually. Starting with the cylinder, you can see the r times cosine t, r times sine t, and z in the x, y, and z dimensions respectively. As well as I would like to highlight the Jacobian volume integral, as you can see in the bottom there. Through doing the hand calculations, I was able to determine that that Jacobian volume was just r. Now moving on to the parameterization for the hemisphere, the hollow hemisphere rather, you can see that the simplest form of that parameterization is r times sine phi times cosine theta, r times cosine phi, as well as r times sine phi times sine theta in the x, y, and z dimensions respectively. After going through and plotting the grid, surfaces, and curves at the appropriate location within the dimensions that of my choosing, I was able to figure out a Jacobian volume, as you can see there, where it's r squared times sine theta. And then finally, the concrete slab is relatively simple, as the simplest parameterization of that is just x1, x2, and x3 in x, y, and z dimensions respectively. And the Jacobian volume of that just turns out to be a series of ones. Shown here is my silo from my code. As you can see, I successfully was able to plot the different shapes. There's the concrete slab, the hollow cylinder, and the hollow hemisphere, and as I drag it around you can see that they are hollow, and so my code successfully worked at plotting what I wanted it to plot. So shown here, I'd just like to highlight a couple of different views in the volume of my body. So as you can see, part 1 is the hollow cylinder, which functions as the shaft of the silo. Part 2 is the hollow hemisphere, and part 3 is the concrete slab that it sits on top of. And you can see that the volume that MATLAB is generating is 1093.2448. Shown on this slide is the derivation of my hollow cylinder's parameterization, as you can see on the left, with the different bounds of the radius, the theta, and the height, all given their respective variables, as well as the derivation of my Jacobian volume, as you can see, just by taking the partial derivatives of the r, theta, and z dimensions respectively. And as you can see there, through my worked out math, my Jacobian volume came out to just be the value r. Similar to the last slide, this is just a simple parameterization and Jacobian volume hand calculation for my hollow hemisphere. And as you can see on the left there, that is the derivation of my simplest sphere for the parameterization shown with the different variables r, phi, and theta. Moving on, you can see the partial derivatives that I took of with respect to r, with respect to theta, and with respect to phi. And working through the math there, I derived that the Jacobian volume came down to be a value of r squared sine theta. Finally, this is just the simplest parameterization to Jacobian volume of my slab. As you can see, the parameterization is just x1 and x2 and x3 for a slab like the one I'm showing, with the different bounds as you can see there, as well as the Jacobian volume that I calculated by hand just coming out to be 1. Where in order to code that into MATLAB, I actually had to create a vector full of ones that was the same size as my x1 dimension. And finally, I was able to verify the volume that MATLAB gave me by doing a series of hand calculations just based off of simple geometry. We all know the equation for a hollow cylinder and a hollow hemisphere can be derived very easily, as well as just the equation for the volume of a slab. And as you can see, working through my math there and summing my totals up, I got a value of 10,093.225, where MATLAB gave me a value of 10,093.2448. So those values are very similar, and therefore I believe my code is working successfully. Thanks for watching.